Right now, though, it looks like I don't have to stall any longer, as Team 1 is making its way over. Alright, so this is Team Distance Medley Relay, and we actually only have one team member here because they are currently taking part in a Distance Medley Relay. So Ozzy here, though, has bravely volunteered to come and talk about the robot. So, can you take me a little bit about the overall design, because you guys have kind of a unique approach to scoring goals.
So we decided to go for a simple approach. We have a one-way gate, and the goal is to just drive right in. So it's 8 inches, so they'll have a 1 inch clearance from the goal.
Sorry, 8 inches what?
Oh, the one-way gate is 8 inches on the front.
Okay, and I believe we guaranteed a depth of that for the goals itself, so that it's guaranteed not to destroy it. Looks like we might be having some technical troubles. So, what was the reason for going with that sort of design?
We wanted to go for a simple approach. Give us enough time to start testing early to see what other problems we may encounter on the course. And looks like it's scoring. So right now it's entering the first part of the phase is wander. So it should break off wander when the camera starts seeing the red pixels and start going into ball fight.
Now, I was unfortunate enough to look through a lot of teams' code, and I've got to say that this team came in and they said we have 2 team members that have taken 100, which is the introductory Java course. We have another person who took 6001, which teaches you Scheme. So relatively little experience coming in, but your code is fantastically simple and does an incredibly effective job. I was very impressed. So, in your software design, what sort of strategies were you doing? What sort of little things should we know about?
So in our software design, we do a little bit of wall calling and then random turning left or right 90 degrees to prevent your particular areas. And then it also has a step limit mechanism. So when it hits a wall and it's unable to move for approximately 3 seconds, it'll start backing up and to make it complete 180 to 360.
Under those random behaviors that happens when you start?
Those are random behaviors.
So robots like humans can be erratic. So if you're docking into the goal though, you're then no longer exploring, right?
Exactly. So in approximately a minute, we're going to enter a find goal mode where it will stop collecting balls and start trying to find the goal. And then it'll start entering the like a parallel parking procedure to get into the goal.
So how do you then know that you've docked? You're in the, let's say theoretically you're in the goal. How does the robot know that that's its status?
It'll hit the bump sensor right out of the front.
So on
it'll break from the entire goal.
So that bump sensor has a priority 1. That gets through everything else.
Yeah.
So it seems to be stuck now. We're going to get to see the random behavior.
Yeah. You're going to see it should start backing up and moving away. It's going to start backing up now and moving away.
So it seems that we
So right now it should start getting fine.
There's a goal right here, so maybe we'll see. So you were saying that you think it sees the goal, but that it had a bad approach angle?
Yeah, it had a bad approach angle. So it's gonna back up and hopefully reset itself. Find the goal again.
So then it remembers though that it's looking for a goal, and it just kind of spins around until it sees it again?
Yes, that's correct.
Let's see if it didn't back up a little bit too far.
Yeah. So you probably see this go coming up right here.
Seems very Can't make up its mind which one to go to parking.
Okay, so it sees this one, so it should back up and try to send it.
Seems like you're doing 3-point turn there to get around. Is that roughly?
Yeah.
So it seems like the approach angle makes or breaks your robot's docking procedure.
Yeah, it does. Yeah, it does.
Oh, nice.
Well, you certainly seem to be picking up balls without a problem. Have you guys tested your maximum storage?
Yeah, our maximum storage is approximately 8 balls, 8 to 9 balls.
Seems to be stuck in a bit of a loop. Sorry, we're blocking your view. Oh, but it's now making its way out. We're nearing down to 30 seconds left, so if it sees this goal, though, it looks like it would be a dead-on shot. Just maybe. Oh no! Oh, it just... Has it stopped?
It's off its balls.
Grasping on for dear life, team distance medley relay has collected 1 ball for 1 point. So, we'd now like to take a slight break from the competition to hear from ITA Software. I could tell you a bit about them, but then I would be stealing someone's job.
This is just amazing. If you've ever tried to do something like this, the fact that these guys could do this in such a short time and do it so well is, I think, incredibly impressive. So, congratulations, everybody. So it's an honor to be able to sponsor this event. We're ITA Software. We're a small software company located really close by. Incredibly fun place to work, terrific people. We have internship opportunities if anyone would like. There's some forums outside in the hallway. And have a terrific time. And thank you very much.
Again, ITA Software powering us much in the same way they power the airline industry. So you can now take a look at the scores. It seems like Tedazu has got a commanding lead with 30 points after a very impressive run. We're now ready to hear from Team 6, Men in Hats.